Today I'm starting a series on exoplanet discoveries, planets around other stars, other worlds outside our solar system. Of course, the driving motivation for this, besides just general curiosity, is: are we alone? Are we alone in the universe? Maybe the greatest question that is yet to be known or to be solved. Are we alone? So the history of exoplanet detection is fascinating, and with errors and missteps. But today we know of over 5,000 planets around other stars, and it appears that stars with planets are the rule rather than the exception. So the series that we're going to start today is about the different ways we've thought about worlds around other stars, the detection methods we use, the technologies, what those worlds are like, what stars they're orbiting, and of course, do they appear to be habitable? Could they be places where life could develop? So today we're going to start, obviously, with the screen. We're going to start not so much with the science, but with the philosophy, because the human condition, are we alone? The human nature has asked this question for thousands of years. And there have been some notable philosophers who have pondered this. Okay, so again, this isn't science. You're not building observation and theory and testing it multiple ways. This is just kind of thinking about things. So I have some interesting quotes here. Thales of Miletus. Now, Miletus was in Greece, I think, at the time, and then this is 2,500 years ago, and is now on the coast of Turkey. And he said, "The stars are other worlds. Earth and everything beyond has a common physical basis." This was an incredible statement, because up until then, and quite beyond that point, the prevailing thought was that the heavens are pure and pristine because they are the heavens and the residence of the gods, and down here with the unwashed masses on Earth, the physics are different. So this was an incredible statement. Let's see. Anaximander of Miletus, again Miletus, 2,500 years ago or so, he said, "Earth is a cylinder. Sun and stars are fires trapped in globular masses by cooler air." What an interesting thought. I mean, how do you dream this stuff up? Diogenes actually kind of got it right. Well, he got it right and wrong. He thought air was intelligent, and I'm not sure how he came up with that. But he also believed that there were infinite worlds out there in the universe, an infinite number of worlds, and that the meteorites that we see, the meteor showers that we see, came from space. There was a lot of debate over whether they were atmospheric or spaceborne. Aristotle, who we regard as a very wise philosopher, he kind of got it wrong. He said the world contains all the material there is, with nothing left over to form any other worlds. So these are just, it's interesting thinking, and unclear how they came about these thoughts. But finally, Isaac Newton, in his great work, The Principia, said that if there are other systems out there, other planets, other stellar systems, they will all be constructed according to a similar design. And that is very similar to the statement of Thales that said that the physics of the universe is the physics of the Earth, and everything is put together in quite the same way. Now, I've saved the best for last, because this is my hero. I actually dress up as this guy for Halloween, and his name is Giordano Bruno. And Bruno was a contemporary of Newton and others, and he believed that the sun was a star, just like the stars you see in the night sky, and that the planets orbited the sun. That was still a matter of debate, and that there are many stars and many stellar systems, and that there are planets, and that there could be life on these planets. Now, he was kind of a rogue guy. Okay, he believed in freedom of religion. He believed you should judge people by their deeds and not their works. And so he was actually quite ahead of his time. And so for that, there he is. There's Giordano Bruno. And here on the lower left, he's brought up in front of an inquisition from the church who really didn't like what he was saying, and labeled a heretic. And so he was executed. And here's a famous painting with Bruno on the left in the white garb and the crosses and the church going to tie him to the stake and burn him alive, which brings to mind the great quote by Max Planck, who said, "Science progresses funeral by funeral." Right? So it takes a lot of courage to, buck the system. We generally believe that 1995 was the first detection of a planet around another star. Actually, to that in just a second. But in fact, there was a detection of a planet around another star in 1917. Who knew? This is an astronomer. His name is Van Manam. And he was looking at high proper motion stars that appear to be moving rather fast across our line of sight, which means they're rather close. And he noticed one that was rather dim that he didn't quite understand. And so he took a spectrum of it. Now, this is back in 1917. They knew very little about stars at that point. In fact, at that point, they didn't even know the galaxy was one of many galaxies. We thought that was all there was. The upper left shows the spectrum of that star. And the two black lines on top and bottom, thick black lines, are references. And the thin line that's broken up in the middle is showing an iron line. Iron in the atmosphere of a star. Very unusual. Very unusual. The spectrum in the bottom right is showing a better spectrum of that star that was taken later, showing calcium and magnesium and iron. And what's unusual about that is this star is a white dwarf. Star much like our sun that ended its life and contracted to a dense mass and has some convection going on. And there should be no metals on the surface. These things eventually, over a period of tens or 100,000 years, should make their way as heavy material down to the core of the star. And that means that something's going on replenishing these materials in the surface of the star, which is where we're seeing them. And that means that this star was once the sun of a planetary system, and that you probably have meteorites or other things that are falling into the star, replenishing its heavy elements on the surface. So I will end today. This is just the first in the series with, in fact, the first discovery of a planet around another star. And this was Beta Pictoris, or if you're in a science convection with a lot of nerdy astrophysicists, they'll just say Beta Pic. This is this was a pulsar, a rotating neutron star. It was discovered that the very regular pulses from the star, from the radio emission from the star, would vary a little bit. And they were varying because there's a planet orbiting the star, pulling it away from us, pulling it towards us, and changing its distance. Therefore, we received its signals at different times. So this is the beginning of our understanding that there are, in fact, verifiably, observably, planets around other stars. And in the weeks to come, we're going to be looking at the technologies that have brought us to the point where there are now over 5,000 planets we've observed and detected around other stars, how we've done it, what those planets are like, and could they harbor life. And so I'll just leave it there, hopefully with a tantalizing message, and we'll resume next week.
Thank you again, Lou. I'd like to take us back to Lou.
Oh, thank you. Just a small correction. I got a bit ahead of myself, getting so excited about this series. Beta Pictoris, in fact, is a main sequence star, a little more massive than our sun. And it was the first detection of a debris field around another star. It has belts where the material seems to be cleared away. It has evidence of higher order, what we call metals material. But the first planetary detection was, in fact, around a a pulsar, as we just found out about pulsars. And that pulsar had the descriptive name PSR B1257. So remember that name. That's his historic name.
Yeah.
And we'll. This was a sneaky way of getting to do the rest of my series today, but we will continue this later.
The amazing thing about that was that nobody expected planets to be found around a pulsar, because a pulsar is a supernova remnant. And how could the planets have survived the supernova? That's the question.
Yeah. Well,
But
maybe that
obviously
it could be that they didn't, and in fact, there's some debris field of small asteroids or
Yeah.
something like that, material just falling on to the surface.